Hello, everybody. Happy 2026. What I want to talk about today is you're a developer and you have some Python code and you want to ship an executable program to a user. How do you turn the Python code into an executable? There are several ways. One of them is Nuitka, and it takes like hours to compile, like a reasonable program. Python, the same. It's really slow, and also, it does not compile your dependencies, does not package them. Just not good for shipping an executable. MyPyC just doesn't work in real programs. For example, I tried to compile my website, alexmark.in, and it just didn't work. It says there's an exception, whatever. It doesn't compile real programs. So, obviously, the next step is to make your own compiler. So the plan is you have the Python code and you take the Python compile function that dumps the bytecode, which is like, you have a bunch of instructions like load an integer, add two numbers, pop something onto stack, load something on from the stack, whatever. Then like my compiler, takes this bytecode, a bunch of instructions, uses, transforms it in dumps C code. And after that, that C code I put into like Clang, TCC, like probably because TCC is faster and as far as I remember, there's no much difference in this specific case when I compile this thing, and it dumps an executable. That's a great plan. Why not do that? All right. So in the previous video, I showed an example of how you can compile a lot of Python code into C very easily, let's say that. And I've been doing some more work on that thing, on the project, and I hit a wall. So essentially what I was doing is writing my own Python runtime. Because, for example, when you have an integer and you want to add it to another integer, in Python, the integers are not like 64-bit integers. They're arbitrary size. So you can have like an integer any size and whatever. So you need to write special function to handle that. Then you need to write special function to handle string operations, for example, replacement, finding, and all of that is a runtime. It's a library code that I need to write for my own runtime. And obviously, when I write it, it's going to be fast and it doesn't have any bloat. It like uses good techniques for writing software, like uses whatever, all the temporary memory buffers, whatever, the memory usage patterns are good. But it also has issues because obviously it's a lot of work to re-implement the whole runtime of Python, the whole standard library, excluding the Python code, but the actual C code. And obviously another biggest issue is none of the modules that you can download from PyPy will work with this thing by default, because you need the whole program to be written in Python. So, another option, which I did not do yet, is using the CPython runtime itself. When you download Python, there's a dynamic library shipped with it, and you can link with that dynamic library and use the functions that, the Python core developers implemented already to have Python work. And I can just reuse the code that is the Python. Obviously, uh, pip, right? I'm sorry, pip, right? Pip works, right? You can just download any module from pip and it will essentially work. There's almost no problem with, interoperability. You can just plug it in essentially. Just import it and the CPython will do its magic thing, loading the compiled module. That's just, works. And the semantics obviously work because, you know, the bugs, the CPython, which is the most popular Python implementation, was, shaped by years of bug reports and users, and a lot of like millions of users, or maybe not millions, but whatever, right? It's like a lot of people have worked on that thing, and it really works well, and I don't need to do almost any implementations of any things. I just kind of do a little bit of glue logic. Just generate a little bit of C glue to use that hardened logic. But also there are cons, right? It's it's not really easy to compile all those modules, especially native modules, and all of the standard library and also the Python dynamic library into one executable. Because what I really like in when I install a program, I don't need to any installation. I just have one executable, I run it, and it just runs. I don't need any installation process, no modules, no nothing. Simple, just one executable. It's much harder to do this here. The best attempt was to have a zip inside of your executable, put the zip, unzip the thing into a temporary folder and use that. Yeah, I hope I will, avoid that as much as possible. But it's kind of hard to do it. And the other problem is, it's really kind of hard to make it run fast because the Python bytecode machine, the virtual machine, was also like had a lot of optimizations put into that. And my glue code is not really optimal right now. So, it also will not really work in the same it will have a degradation of performance. When I just run with Python, it will have certain performance, and when I compile with my compiler, it will have probably worse performance unless I spend a lot of time on that. Okay, but what should I choose, right? I currently have it's written in my own runtime. Well, you see, this is not my first rodeo here. I've done a compiler, Python compilers, a lot of them, probably, but one of the biggest attempts was Python, which what it did is it it was doing a lot of type analysis, a lot of static analysis, the value analysis, like you try to propagate all the constants and all the things, a lot of optimizations, right? I was doing my parsing, my IST, my bytecode generation, whatever, right? It was a big project. It took a lot of years to do. And eventually it became just, I couldn't work on it. I didn't have the motivation. And because the biggest issue was that I implemented my own runtime with, all the standard objects and all their methods, maybe not all, but at least some. And it's so hard to do. It's a lot of work, and it didn't even work quite correctly. So obviously the GC was shitty, and it didn't work with real programs. I couldn't, use any compiled modules. No NumPy, no, I don't know, PySide, whatever, right? None of that just worked. It needed separate glue. It just was not good, right? But it obviously did when the program was written in essentially its own language. It was not really Python at that point, I guess. It really ran faster, much faster than the Python thing because of all the optimizations and all the type analysis and whatever. What I'm doing right now is I want to have the dumbest implementation possible, which is actually compatible with CPython, because this is the biggest issue with any Python compiler. You want almost like most of the code written out there to actually work with your compiler. But if it doesn't, your compiler is useless. Most of the code cannot work with it. What's the point? You need to rewrite it in a separate Python-ish language. No, I just want my code, put it through the compiler, and it's compiled into an executable and probably faster. I don't want to rewrite it in any way. So, obviously the con is if you're doing the stupidest implementation, which is the most compatible because you're using the Python dynamic library, it's going to be slower. But, it's actually fine for now, because what I want to do is I want to get it to the point where it actually compiles the programs, like most of the programs, and they actually run correctly. And after that, I can apply all the experience I had with CPython to actually make it work really fast, do some optimizations potentially with profiling, profile guided optimizations for your Python program. Sounds interesting. So, yeah, in quick demo, I have transformed, my compiler into using Python, CPython dynamic library. Um, Let me show it to you, right? So I have a demo file. Yeah, just a very simple program, nothing fancy. I just want to get the point across. Okay, and I can run this. So I'm running it with Python. Here's my compiler, and compile and run the demo program. I'm using TCC because, like, actually, from my experience, compiling with Clang or TCC right now doesn't give any changes, because I'm not doing, like, I'm doing a bunch of glue code. I'm not doing really, I'm not transforming it optimally, the bytecode. So it works, compiled in under a second because I'm recording. It's usually faster, generation time quite fast, quite lean. So what I want to do is I don't want to dump a bunch of standard library of your compiler into the C code, just because why not? What if we need it? It's kind of shitty, I cannot read output of Nuitka nor Python. They just dump a bunch of C code. I'm like, where is my thing, right? Not your thing. So yeah, let me show you what it um, outputted. Output C. Yeah, you see, just here's the main function, and we just load in the name, pushing some arguments, pushing constants, calling things, just quite dumb glue code. No optimizations, I could definitely cut on some reference counting, but it's all later. When it actually works and runs the real code, I will make it go fast. But, gotta make it work before optimizing. Yeah. All right. What do you think about that? Because from my experience, there are no really good compilers for Python. Like, all of them are kind of niche-ish, or like not really, don't have any good experience. So I feel like there's an ability to improve on that space, to make an actually good tool. So because I'm seeing the CPython team doing the optimizations on the fast CPython project, and doing all the JIT and all the um, smaller bytecode. I don't remember, not the bytecode. They call it something like whatever. They're doing just-in-time compilation. But I'm like, why not do the same thing, copy and patch the code for the bytecode machine, but do it ahead of time? Because when you do it ahead of time, you can do profile-guided optimizations on it. So I feel like if I what I was doing right now, what I'm doing right now is I'm literally using the disassembly module just to skip all the parsing, all the transforming from AST into bytecode, just to get it working. And once it actually works and it's useful, hey, why not make your own parser, whatever, make your own optimization passes. That all can be done, because I feel like just making it most programs work and compile is also a hard task. Yeah, and especially if you want to make it just in one executable and not just package everything into zip. All right, leave your feedback. What do you think? Would you want to use a compiler like that? Which actually, like, my goal is to compile most of the programs really fast. So, if you have an actual application with, like, I don't know, 100,000 lines of Python code, it shouldn't take more than, like, I don't know, 5 seconds to compile it. Like, it should be really fast, especially on a, not release build, but even the release build shouldn't be that big. So yeah. All right. If you want to learn more about me or the project, you can check out the alexmark.in website. Bye-bye.